So yeah, we're going to talk a little bit about how we got here, and then a bunch about what an enterprise Apache Hadoop platform looks like, and then some of the current and emerging technology investments in Hadoop that I'm very excited about. So let's start by looking backwards. All right, so this is actually a graph from a recent Yahoo presentation, and it tells a couple of stories. First of all, it tells the story of the huge growth in usage of Hadoop at Yahoo. You can see there's two lines there. One is the number of nodes that are used, and it goes from 0 in 2006 to 42,000 unique computers all running Hadoop inside Yahoo today. And the other line is the number of petabytes of storage deployed, Hadoop storage deployed. So that's roughly 350 petabytes of spinning disk at Yahoo in HDFS today. So huge growth, but it's actually, I mean, the reason that I really like this graph is it's also kind of a story of how we got here as a community. So back in 2005, 2006, we decided to invest in an open source big data platform at Yahoo. At that time, both Doug Cutting and I were at Yahoo. And sort of Hadoop was the fusion of two strands of DNA. Doug had built Hadoop as a prototype inside a web search project, and we combined that with the team that had built, you know, a web scale enterprise search engine. So we were crawling and indexing every document in the web, and we wanted a new framework to do that. And we decided we wanted to do that in open source for a couple of reasons. One of them being that would be the best way on earth for Yahoo to advertise that it was hiring data scientists. If they were trained in this technology in school, then they would know that Yahoo would be a great place to come and do that. And that's been a wild success over the years. But so, I mean, if you think back to Matt Aslett's graph, there was a couple graphs yesterday. There are a couple of really interesting things he asserted that I really agree with. I mean, first of all, you can see today that between Hortonworks and Yahoo, we're continuing to do a lot of the investment in Hadoop, and we're very proud and excited about that. But you can also see the diversity of contribution. So back in 2006, of course, Hadoop was a much, much, much smaller code base. But the other thing he talked about was sort of the ways that an enterprise comes into Hadoop and the things that they learn over time. And so let me just sort of review that learning in Yahoo. So back in 2006, we set this goal. We were going to take this prototype in the Lucene project. We spun it out into Hadoop, and then we started running releases. Originally, a release was happening every month, and it's a bit slower now, but we released early and often. And we went from being able to support 20 node clusters in the beginning of 2006 to about 100 node, 200 node clusters later in 2006. And that number kept growing. Today it's about 4,000 nodes, 4,000 computers in a single Hadoop cluster. And so we were looking at that growth and saying, well, to solve the web search problem that we've set out to solve, we need to have 1,000, 2,000 node clusters so we can manage petabytes of data in a single cluster. That's going to take us a few years. So how can we show value today? And we took up the idea of putting interesting data sets from advertising, from web search, and giving them to Yahoo's data scientists. So we put up some clusters and let them start using this data. And what we thought was, this is going to be a great way for us to get science results that'll help inform the design of our next products. And that was fairly successful. But then something else happened that we had not anticipated, which is the scientists came back to us into their management and said, we have built, using the data that was available on Hadoop, a new prototype that we would like to take to production on Hadoop. And if we can run these Hadoop jobs every 15 minutes, then we will have better ad targeting at Yahoo, and therefore Yahoo will make more money. And so buy us a bigger Hadoop cluster, and we will raise Yahoo's profits by 1%, 2%. That woke up management real fast. That's why you see those lines going up really fast. And so we found ourselves in this kind of unanticipated virtuous cycle where we were, by giving Hadoop to scientists and developers at Yahoo, they were prototyping new apps and just moving the whole organization in a much more agile fashion. Hadoop was driving innovation, and that innovation led to more investment in Hadoop, and this great sort of internal community dynamic was started. where Hadoop's success drove more investment in Hadoop. And then in about 2008, it really, things really got interesting, because then all of a sudden we were seeing not just individuals from the community contribute, which had been happening since the beginning of the project, but we started to see new organizations start to make bets on Hadoop and start to contribute. So that's when Facebook in particular started to contribute, Hive, and then the whole thing started to gain momentum. And then again, 2009, 2010, you started to see vendors coming in, Amazon and Cloudera and IBM, and people were starting to say, look, we can start to build businesses around Hadoop. And again, the whole thing just started to accelerate as more people used it, more people contributed to it. So, sort of looking at all this, we reached the decision point in 2010 that, at this point, there's a big enough opportunity here to bring Hadoop to the enterprise that we can actually accelerate the open source project faster as an independent company than inside Yahoo, right? We can service Yahoo and the rest of the community by, forming a company whose mission is to build completely open source product and support it for the enterprise. So that's how Hortonworks got here today. We spun off the company from Yahoo in 2011. But we've been functioning as the organization that's managed and released in Apache every release of Apache Hadoop since Hadoop's inception in 2006. So a young company with a long history. What does it mean to produce enterprise Apache Hadoop? Right, so we have a fairly unique process at Hortonworks. We start by doing what any software company does when it sets out to build product. We go and interview the users of Hadoop. We sort of identify requirements that would either make it easier for current users of Hadoop to get more value from it, or would bring Hadoop into new use cases. So once you've identified those requirements, the thing that's a little different about our process is that we develop new software in the Apache Hadoop community with collaborators in the wider community. So then once we do that, then we package up a distribution, and then we bring sort of enterprise-grade testing to make sure that the final product is enterprise consumable and stable. So what is an enterprise distribution of Hadoop? Well, you start out with the Apache Hadoop core, of course, MapReduce HDFS. That's where it all started. That's what Apache Hadoop is technically. But then you add a series of other open source projects from Apache. Flume Scoop to make it much easier to ingest data into Hadoop. Hive, Pig, HBase, and HCatalog to make it much easier to manage your data in Hadoop and to interrogate it, transform it. And then you add a series of Apache Hadoop projects to both manage and monitor the clusters and to manage and monitor your jobs and workflows, Ambari and Uzi. And then you're done. Everything's open source, everything's in Apache. And then you have the Hortonworks data platform. Then you test and package that to make sure that it runs on every major OS, in the major clouds, and in the appliance form factors so that it's as easy as possible for everybody to download, consume it, and use it. So that's what the Hortonworks product is. So let me change gears and talk a little bit about the sort of projects in the current distribution of Apache Hadoop that we're very excited about. One is HCatalog. This takes the table level abstractions of Hive and sort of opens them up so that all of the data tools in Hadoop can work at this higher level of abstraction. Now you can take a table and use a Hive, you can write it with MapReduce or ETL it with Pig, store it in Hive format, use it directly, just interoperate between all those tools. And it also opens up all that data so that it's accessible from outside the cluster, which is very important. You can now use third-party SQL tools, look at it as a table directly, and just it opens up Hadoop to just many more use cases. Very exciting to up-level the management of data in Hadoop. And another one that we're very excited about and proud of is Ambari. So Ambari is a Apache incubator project, the focus of which is to bring provisioning, management, and monitoring of Apache Hadoop to everybody as an open source project. And a particular focus in learning for our team over the last year has been that, when you go talk to the enterprise user, they say, well, it's great that you've built another user interface to manage and monitor Hadoop, but I have 27 screens already, and you want to add a 28th. What I really want is to integrate it with my favorite enterprise management tools, not have another one. So a real focus of Ambari has been to add APIs. Everything that Ambari does, it does through RESTful APIs, and that means it's very easy to integrate it into existing management suites. Other highlights of Ambari is that we're adding job diagnostics so that it becomes much easier for users to directly diagnose what's happening to their jobs in Hadoop, why they're running slow, why they're failing. Cluster history so that you can see what's happening today, what happened yesterday, and much easier sort of direct navigational access so in a glance you can tell what's happening in my cluster right now. Is everything healthy? If not, what's not? So that's Ambari. So you put all that together, you have a distribution. A lot of times it's hard to really get started. So the easiest way to get started with Hadoop that I know is the Hortonworks sandbox. This is a downloadable VM from our website that lets you see, learn, and do Hadoop in minutes on your own desktop. It's a great way to learn Hadoop for the first time or just sort of try out the new features that are available in the Hortonworks data platform. So I'd encourage you all to try it. So with that, let's change gears and talk a bit about the future of Apache Hadoop. So you can't talk about the sort of future of Apache Hadoop without talking about Hadoop 2.0. This is basically a rewrite, a refactoring of the whole Hadoop platform that's been in the works since 2009. So a tremendous amount of work. It's now in alpha, and we're very excited because we believe that it's going to move from a place where it's still sort of cutting edge, early work to beta this year, and then within the year we think it's going to move GA. So that's going to have a lot of impact. So what are the sort of the key improvements in Hadoop 2.0? So there's two real focuses. One is just scale. So today, as I said, the largest clusters that we know of are 4,000, 4,500 nodes, nodes being computers. And those clusters are mostly built out of computers that are at this point a year or two old. As you look at computers keep getting bigger, and so when we set a goal of 10,000 nodes for Hadoop 2.0, that's 10,000 of next year's nodes. So that really means an order of magnitude more data that can be managed, an order of magnitude more computation that can be managed in a Hadoop cluster. And that matters not just to the small number of organizations that are likely to run a 10,000 node Hadoop cluster next year. It also matters to anybody who is selecting Hadoop for their enterprise because they want a data management framework that they believe will grow with them. I think that's why most people choose Hadoop. All right? My definition of big data is you have a big data problem when your existing tools or techniques either just can't solve your problem at all or can't solve it cost effectively. So the fact that Hadoop will continue to scale will, I believe, continue to cement its place as the sort of de facto solution for big data problems. But beyond that scalability, a real focus is extensibility. So that's where Yarn comes in. So Yarn is a refactoring of the processing model of Hadoop. In Hadoop 1.0, you have one programming model, it's MapReduce. In Hadoop 2.0, we've separated out the sort of core resource management, the ability to allocate a certain fraction of your cluster to a particular set of work from MapReduce. So now MapReduce just becomes one of a number of programming models that you can use with your Hadoop cluster. So along with MapReduce, you're going to see new frameworks becoming available. And what's very exciting is they're already becoming available. We're seeing people develop frameworks to do streaming, to support lower latency SQL queries, and more generally to provide new kinds of services. For example, there's a proposed project to bring a Cloud Foundry to Hadoop as a service. So, this idea of just opening up Hadoop for more kinds of innovation is really exciting, and we look forward to seeing what that will bring. There's already lots of positive signs. So let's talk about one of those new frameworks. So Tez is an Apache incubator project that we talked about some yesterday. Arun Murthy is the champion of that in Apache. And Tez's focus is really on providing a much better programming framework in Apache Hadoop 2.0 for low latency queries. So that breaks down into two pieces. One is a real focus on the sort of inner loop. How do we more efficiently process lots and lots and lots of rows of data? And the other focus is just on how do we start a computation much more quickly? How do we make sure that the cluster is kind of warmed and ready so that when you submit a query, it's running your query in seconds, not minutes, right? Tens of seconds, not to exaggerate. So Tez is very exciting, but it's part of a larger initiative. When we talk about Stinger, people say, I haven't seen Stinger in Apache. That's because it's not a project, it's a collection, it's an initiative. It's a bunch of different people in the community collaborating together to make Hive much, much, much better, with a key focus on supporting low latency SQL in Hadoop, right? We believe that Hive is the natural way to support low latency SQL in Hadoop because it's already the de facto standard for SQL in Hadoop. It's already proven to work at scale, to be stable across many, many workloads. And it's very full-featured. So if we can take what exists and incrementally improve it, then we believe that we'll be able to deliver a stream of really stable releases that do more and more things. So that's sort of our general theme of taking what exists in the community and then developing it, improving it in the community, and providing a stream of incremental improvements. So we think this is the way to go. And a lot of other organizations are working with us to make Hive much better. So how do you do that? Well, you kind of decompose the problem and look at the opportunities for improvement, and there's sort of three major themes. I've already talked about Tez. Also, there's just a lot of work in core Hive to produce better query plans. If you can do your work in fewer jobs, things are going to run faster. And then another opportunity for improvement is a better columnar store format. And Owen O'Malley is championing the optimized RC file project that is going to just represent data much more efficiently and allow it to be accessed in columnar format. So your queries will run much faster if you read much less data off disk. So you put all that together, and we think there's more than an opportunity for 100x improvement. And not only that there's that opportunity, but that it can be delivered incrementally in a sort of stable Hadoop scale way that will not only address the interactive use case, but will also continue to be the best framework for very large queries and very large workloads, and that we'll have one tool with the same syntax, the same semantics across all those workloads. So we're very excited about the Stinger initiative. And there's a talk later today by Gopal and Vinod that'll talk about some of our early results where we've already seen benchmarks that are showing, on the order of a 40x improvement. So we're very optimistic that this is a tractable project that's going to deliver stable software very quickly. So in the theme of showing, right, because this is all happening in the Apache community and open source, you can try a lot of this today. So we're announcing the Hortonworks Data Platform 2.0 Alpha 2, and that includes the first release of Apache Hadoop with Tez. And this gives you a full 2.0 stack that lets you start to see the value of all this. Again, it's alpha, but it's because we're developing in the community, as it evolves, you can be part of it, you can try it, you can help us. So I'd encourage everyone to give that a try who's interested. So just sort of continuing the survey of major investment themes that are going to be coming into the community this year. Knox is a new incubator project that was announced in the last few months with a focus, well, so again, Knox is a theme that we and a number of other members of the community are focused on. the theme is let's figure out how to make Hadoop security both much simpler to operate and much stronger. An incremental deliverable along that journey is the Knox gateway. The idea there is let's build a REST proxy that can be put in front of a Hadoop cluster that will provide single sign-on using existing enterprise tools, and then allow you to use Hadoop exactly how you're using it today. So that's a new incubator project that we believe will be part of providing a much simpler and more secure Hadoop in the future. And finally, the newest sort of Hadoop initiative is the Falcon project. This is a new community project developed at Imobi in India that we're very excited to be bringing to the Hadoop community with the help of Hortonworks and Yahoo. So the Falcon project is really focused on automating the management of data in Hadoop. So there's kind of two sets of problems there. One is data lifecycle and data movement. How do you get data into the cluster? How do you move it between clusters? Make sure that you keep the data in the right place for the right amount of time. And the other is how do I automate ETL flows in a much simpler, more declarative fashion. So Falcon is a new open source project being brought to the Apache Hadoop community that we're very excited about, that we think will have a lot of impact in the coming months and years. So there's a lot going on, and the reason that I'm really excited about events like this is because we get to interact with the wider community. So let me invite all of you guys to get involved. You can get involved, of course, by downloading and using Hadoop. We'd also love to see you all contribute. So today is a great opportunity to talk about that. I'll be here the rest of the day if you have questions about what's going on. And this is also just a great opportunity because we have many of the core committers and contributors to a lot of the Hadoop projects here today. So I would encourage you to stop by and talk to all the guys with the Hortonworks shirts on if you're interested in learning more about all the various initiatives that I talked about. So thank you very much.
So thank you, Eric. So just as a guideline for everybody, so this is a summit. This is the first time doing this in Europe, right? Mm-hmm. How many of these summits have you done so far? You've stood up and talked about Hadoop and where it's going.
Every year since 2008.
Every year, so this is your sixth one you're going in front?
Fifth or sixth,
okay.
Yep.
And the first one, how many people were in the room when you did the first one?
So less than this. I would say we had about 200 people in the room in 2008. So it's really encouraging to see this many people already in Europe. I think that, as you said, we'll definitely be back because we're seeing just a huge engagement and excitement about Hadoop already.
Great. Well, thank you, Eric. Thank you very much.
Yeah.
Okay. All right.